So we're on rational expressions, topic number 15, and we're going to show how we apply Desmos here. So just going to go over a couple of things. You may remember that we talked about a minus b over b minus a equal to minus 1. And so it could be x minus y or y minus x. As long as this term and this term are the same and the coefficients are the same, it'll work out to be minus 1. And here I put a minus b over b minus a, and I get minus 1. So the rationale for this is that if we take a minus 1, we can put a minus 1 here times b gives me minus b, and minus 1 times minus a gives me plus a, which is this term here. So this and this are equivalent, are the same. And then we can cancel the b minus a on the top and the bottom, and we're left with minus 1. So another, if we go to page 77, we can look at an example of inverting and multiplying where I got to divide 2 minus x over 15 by x minus 2 over 3. So I've changed the x into the a here. And you can see that we get minus 0.2, which is the same as minus a fifth right here, the answer. And now what I've done is I've flipped the denominator. Here is the denominator. So I invert it, and it becomes 3 minus a minus 2, and I've gone from division to multiplication. And in this case, actually, you can see 2 minus a over a minus 2 is minus 1. And so minus 1 times 3 over 15 gives you minus 2. So this expression and this expression are the same. And what we've done here, it was shown in the problem, you take the divide sign, you change it to a multiply, you put the denominator into the numerator, and you put the numerator into the denominator, which means that essentially you flip and multiply, or you invert and multiply, and here you see the same thing, so we get the same answer. So now if we go to page 80, number 3k, and we put the problem in here, a squared minus 1, 3a squared plus 4a plus 1, and here we put this term in here, 9a squared minus 1 over 3a squared minus 4a plus 1. Notice that the answer comes out to be 1. Now what we do is we factor the a squared minus 1, which becomes difference of squares, which is this, a plus 1 times a minus 1. This is also a difference in squares, so it's 3a plus 1 and 3a minus 1. And then we factor this term, and we get 3a plus 1 and a plus 1. Notice the inner and outer, a plus 3a gives me the middle term, the 4a. The 3a times the a gives me the 3a squared, and the 1 times the 1 gives me the plus 1 here. Now this one is exactly the same, except we make the two signs negative here, so we get minus 4a instead of plus 4a. Everything else is the same. And you can see what happens here. Let's see, we can do this and this cancel, this and that cancel. A minus 1 cancels with the a minus 1, and the a plus 1 cancels with the a plus 1. I don't know if I mentioned this will cancel. Anyway, everything cancels here. This is the same as that. That's the same as that. The a plus 1s cancel, and the a minus 1 cancel, and you're left with 1. So this term and this one is the same. Now here what we've done is what I said before, break the problem down into smaller steps. If you're trying to diagnose an error, then maybe you'll find Desmos useful. Let's take this problem here. I've entered it here into box 2. 3a squared minus 6 over a squared plus a minus 20. This is problem page 81, number 6i. So Here I have a minus 9 over a squared plus a minus 20 to a squared plus a plus 1 over a squared plus a minus 20. Now the key thing here is that all the denominators are the same. So I just put the denominator down here. Here's the numerator for the first term. I put a bracket around the second term, and I put a bracket around the first. You don't have to. You can go directly and go to the next line. But here, I've got 3a squared minus 6 plus a minus 9. And because there's an implied 1 right here, outside the bracket, I get minus 2a squared minus 1 times plus a gives me minus a, and minus 1 times plus 1 gives me minus 1. And you see the value doesn't change. Of course, I should change the value of a to make sure this happens. Be careful that you don't choose a value for a that makes the denominator 0, because then it will be undefined. For example, if I chose a equals 4, this would be 16 plus 4 minus 20, which would be 20 minus 20, 0. This would be undefined, so you can't use a here. That's why you should always check the slider and vary the value. Now, once I've removed the bracket, I've got this. Now I'm going to group the terms. 3a squared minus 2a squared gives me a squared. The plus a and the minus a cancel to 0. And I got minus 6, minus 9, excuse me, minus 1 comes out to be minus 16. Plus a and the minus a cancel. Now what I do is I factor this as a plus 4, a minus 4, difference of squares. I factor this. You can see I get plus 5a as the inner, minus 4a as the outer. That sums to plus a. Notice the value doesn't change. And then I finally cancel the a minus 4 on the top and bottom. I'm left with a plus 5, a plus 4 over a plus 5.9. Now you see, what I'm trying to illustrate here is we've taken a problem, we've broken it down into 1, 2, 3, 4, 5 steps, and makes a problem a lot simpler if we can do that step by step rather than trying to go a little fast, miss out a step, and then not know why we've done that. Now, here we're working on problem number 82, page 82, number 8H. I've entered the problem here, set a equal to 4. And now I've taken the common denominator, 1 minus a times 1 plus a right here. And of course I'll have 1 plus a up here and 1 minus a here, because what we're doing is we're dividing this into that, and we're left with 1 plus a, which we're going to multiply the numerator here by. Now, I'll agree that I'm going fast here, but we should really have mastered this topic 15, before we come to the Desmos. So go back to the problem, go back to the video if necessary, and make sure you understand that. Now, because the numerator here, or the denominator here, and the denominator here are the same, we can cancel. When the denominator for the top part of the numerator part of the fraction, this and this are the same, we cancel, and we're left with 2 over 1 plus a minus 1 minus a. Notice, no change. No change. So we're reasonably assured that we've done everything right. Now we have the 1 minus the 1 cancel to 0. A over a becomes 2a. I can cancel the 2 and I got 1 over a. So again, we've broken this problem down into a lot of smaller steps, and we've covered these. So, okay, let's go to the last problem that we're going to discuss here. Page 83, number 8N. Here are all the steps here that we went through. when we discussed that. And now I've entered the problem here. Change the x for the a. And now in the first step, I brought the a squared down to the denominator. I brought the a minus 1 here down to a plus. And the 25 over a to the minus 2 is 25 over a squared. Value doesn't change. Good sign. Now I get a common denominator for the top part here, which is a squared. So I have a squared minus 25. Common denominator for the bottom part of the fraction here is a squared, and this will make this a squared plus 10a plus 25. A squared plus 10a plus 25. Now this and this are the same, so I can cancel. I'm left with a squared minus 25 over a squared plus 10a plus 25. Now this is the difference of squares. I get 8 minus 5, 8 plus 5. This can be factored as 8 plus 5, 8 plus 5. Notice as I move this all the way down here, and I've done the problem in many steps, the value here doesn't change. Change the value of the slider to make sure that there's no change. Now the 8 plus 5 cancels. I'm left with a minus 5 over a plus 5. Go back over here, a minus 5 over a plus 5. In the previous problem, by the way, all the steps are given here, so you can see them before you even go, and we did these in detail before. So that pretty much completes our discussion of the application of topic 15 to Desmos.